Okay, so how do we solve equations, trig equations? So there's a couple of things you have to do. Sometimes they're going to tell me on a certain range. On this question, they're not telling me at all. They're just saying find all possible values of the angles that have a sine of 1/2. Well, one thing you can do, remember, sine is the y coordinate. Remember, each one of these points is an x and a y. And we learned earlier that's the cosine of the angle, sine of the angle. So the sine is y. So since this is saying when is sine equal to 1/2? When is the y coordinate equal to positive 1/2? Well, I see it right there. I also see another one there. So, and we usually do these in terms of a radian measure, not degree measure. So the first answer is going to be pi over 6. The second answer is going to be 5 pi over 6, right? And I'm getting that just to make sure I see where I'm getting that. That angle is pi over 6, and that angle is 5 pi over 6. Now, because they're saying all possible values, well, all of these down here, like if you look at 7 pi over 6, that's negative. And if I look at 11 pi over 6, that's negative. I mean, I could say negative pi over 6 if I wanted to, but negative angles, I try to avoid them when I can. So what we're going to think about is how can I get back to that pi over 6? Remember, this is going around the circle many, many, many times. That's how those sine graphs become, right? Because a graph on the y coordinate and it hits 1/2 many, many times. So if I wanted to come back to pi over 6, wouldn't I have to add one full rotation? So I'm going to add plus 2 pi. Then we typically use k or n to say however many times around you want to go, that's what you add. So then the same thing can be said about 5 pi over 6. I have to add 2 pi over k, because a couple of reasons. Well, we know the period of this function is 2. If I graphed it, what would I see? I would see a graph. Let's see, it starts there, it maxes out at pi over 2, it zeroes out at pi, it bottoms out at 3 pi over 2, and it's back to the midline at 2 pi, and it would look something like this, right? It would max out at 1, -1, so there, 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 and there. So that's that graph. And basically what I'm trying to say is, when is this graph equal to 1/2? So about there and about there, whatever those values are. Actually, we know those values. This first one is pi over 6. The second one is 5 pi over 6, not quite pi. And we can see that on the unit circle. And then to get the next one, well, it'd be way over here on the other side of 2 pi. Well, we know the other side of 2 pi is going to be, let's see, 2 pi is 12 pi over 6. So the next solution would be 13 pi over 6, right? And then we keep going. I could add 2 pi more, or 12 pi, so 25 pi over 6. And I don't want to list all those, so this is the convenient way to do that. Okay? Now, when the period changes, this changes, and we'll talk about that as we come there. Okay? So now we're trying to solve a tan function. And, well, I know cosine is x, sine is y, but what's tangent? Well, remember, it's opposite over adjacent, or sine over cosine. So the only way this can happen, the only way this can happen is when the sine of the angle and the cosine of the angle are exactly the same. So I see one here. I don't see one there. That's not true. That's because won't that be, one's negative, one's positive. But here's one that's true. And then I don't see it again until I get back here. So pi over 4, then the next solution, then I could go all the way around again, but except we know the period of tangent is pi. We just did that back in section 2, right? So we know the period is pi units long, period, for tangent, cotangent. So here's the next answer. Isn't that pi radians, or 180 degrees? And then to get the next answer, it's another pi radians, or 180 degrees. So we can say plus pi k, and that'll cover them all. Okay, now again, that's if this period is still pi. If it's a different number, well, then we'll have to adjust in this piece. And that's for all possible solutions. If they give you a range, if they had said on 0 to 2 pi, then we would have only had to list pi over 4 and 5 pi over 4. And we would have been done. Okay? Okay, a circle with a radius 5 square roots of 2 intersects the line x equals -5 at 2 points. Find the angles. Okay, so one thing that we haven't done yet this year is what's the equation of a circle? Well, it just so happens that's the equation of a circle centered at the origin, right? More generally, it's x minus h squared plus y minus h squared equals r squared, and that's with a center at hk, at the point x is the xy, okay? And we'll do some more of this later on in the year where we're looking at the conic sections. We're going to do that to make White Mountain Community College happy. So that's that. But for this one, we know it's going to be x squared plus y squared equals 5 square roots of 2 squared. Well, to make our work a little easier, we got that 5 out from underneath the radical by thinking it's the square root of 25 times the square root of 2, which is the square root of 50. So we could just think about this radius as being the square root of 50 and square that. So that's going to be x squared plus y squared equals the square root of 50 squared, which is 50. Now, this intersects. So we need to substitute in now. We know, I got to draw a picture, folks. I should draw a picture for you. So here, I'll do this right here. Whoops. So we've got the xy axis. We know this circle is centered at the origin. It's got a radius of, I don't know, 7 or so. But we know it crosses that line, x equals -5 at 2 places. And since we know x is -5, all we got to do is substitute that in here and solve it for y. Well, that'll be 25. 50 minus 25 is 25. And when we take the square root, we know y equals plus or minus 5. So these points right here, they are 5, -5, 5, and -5, -5. So then they're asking us to find what is this angle? What is that angle? Well, what I'm noticing is that this looks like this is an isosceles triangle. Both of those are 5. If that's the case, and this is a right angle, which we know it is, that means that has to be 45 degrees, or pi over 4. So that blue angle will be pi minus pi over 4, so 3 pi over 4. And the other one will be a quarter of pi more than pi, so 5 pi over 4. So those are those two angles, right? There's that one, and maybe I better make this, no, let's use green. So then this angle here is 5 pi over 4. And that kind of makes sense. We didn't even need to use inverse trig. If it was something wonky, then we'd have to say the arc tangent. And once we know those points, we can do the arc tangent, find the reference angle, and then figure that out that way. But that's not what they're asking here. Okay, so what they're going to give you is this. They aren't going to give you this. And I wanted to show you this so you could see these are two answers. So I graphed the function. I graphed the horizontal line y equals 9 because we want to know when is the height equal to 9. And then I decided just to cut it off one period because one day is 24 hours, right? And we can see between 2 a.m. and 10 a.m. the water is going to be higher than 9 or higher, right? So how do we do this analytically? Because I'm going to ask you to do that. So what we're going to do is you're going to say if y is 9, y equals 4 sine of pi over 12t plus 7, and we're going to solve. So really what I've got is this is kind of like my variable because it's got the variable in it, and I don't know the sine of what angle. So that's kind of like my variable. So I'm going to isolate that. I'm going to subtract 7, divide by 4. Well, when you subtract 7, you get 2, and divide by 4, you get 1/2. So when does 1/2 equals the sine of whatever this thing is? Actually, you know what I'm going to do? Is I'm just going to say this mess here, whatever's there in the middle, I want to know when the sine of that mess in the middle is equal to 1/2. And this was the very first question we answered in this video. I said, when does the sine equal 1/2? And we found out that it was at pi over 6 and at 5 pi over 6. And that's what that mess in the middle is equal to. So that mess in the middle just happens to be pi over 12t, and this is pi over 12t. So I'm going to divide by pi over 12, which is the same as multiplying by 12 over pi, times pi over 6. In that case, the pi's cancel out. 12 divided by 6 is 2. Lo and behold, that's our first time. And then we're going to divide by pi over 12, which is the same as multiplying by 12 over pi, times 5 pi over 6. The pi's cancel out, the 12's cancel out, the 12 and the 6 cancel out, so I get 2. 2 times 5 is 10. And wasn't that our other time? I hope so, man. Yeah, 10. So there's how we did it analytically. Okay. So here's another sine function or sine equation we have to solve. And like before, we want to isolate the sine. So I'm going to add 1, divide by 4. Whoops, so let me get a pen going here. So the sine of, I'll write 5t, but I'm going to really just pretend it's some like a yellow blob like before. I'm going to add 1, divide by 4. Isn't that 1/2? And boy, this is popping up all the time, isn't it? Don't you see that 5t equals pi over 6? And they also say all possible values. So if you think back to what we did that time, didn't we have to go all the way around? Okay. And you're probably saying, well, this has a different period, Mr. LeMay. It does, and we're going to take care of that in a minute. Now, the other solution was 5 pi over 6. And then we can look at that. If you don't remember where I got that, take a look at the unit circle and see that the y value equals 1/2. And that equals 5t. So now what we're going to do is we're going to divide by 5. And remember, dividing by 5 is the same as multiplying by 1/5. And the reason that's important is that helps us deal with these fractions. And same deal here. We're going to divide by 5, multiply by 1/5. So if we distribute this, I'm going to get pi over 30 plus 2 pi over 5k. In other words, there's going to be a lot of solutions between 0 and 2 pi. It's a good thing they didn't make us list them all. So then again, 1/5 times 5 pi over 6, you see how the 5's cancel out? So I'm left with pi over 6 plus 2 pi over 5k. So there's my expressions to find all possible values. Okay. So now we're going to use our calculator to find the arcsine of, right? Because if we want to solve this for theta, we want to do the arcsine of both sides, and that cancels out the sine, but it doesn't cancel out it will give us an angle for 0.8. So I know it's probably going to be in, it'll probably tell us in, now what you got to remember from that work we did last week, or earlier this week. When did we do this? We did this last week. Arcsine gives us output negative pi over 2 to positive pi over 2, because otherwise it's not a function, right? So when I do the arcsine of a positive angle, I know this angle, whatever it is, that angle right there, will have a sine of 0.8. And of course, I don't know what that is. It's not one of the nice unit circle numbers. So I'm going to grab my calculator. Whether you use Desmos, I think, does it. You can also download, your phone calculators do it. You can also download that TI-84 emulator that I pointed out to you. So I'm going to make sure I'm in radian mode, because remember, we always do these in radian mode unless they tell us otherwise. So I'm going to do the second sine, arcsine of 0.8. I'm getting 0.92, let's see, 0.9273 radians. Okay, so that means not quite 1 radian. Remember, 1 radian is about there. So remember that this length, and this length are the same. That'd be 1 radian. This isn't quite that far. So that's a solution. That's one solution. What if I wanted all solutions? Well, where else is the sine equal to positive 0.8? That's what this is asking, right? That's what this is asking. And so I hope you realize, oh, over here, all trig ratios are positive. The sine trig ratio and the cosecant trig ratio are positive over here. So that's the other angle. We know this reference angle is 0.927 here. Let me go to black. 0.9273. So I want to find this angle. Well, isn't that just pi minus 0.9273? So on my calculator, I'm going to do pi minus that answer. And so that's going to be 2.2143 radians. So that's two solutions. And since I asked you for all solutions, now we're back to that whole idea is in order to get back here, I have to go all the way around. So I'm going to add, let me go to green, plus 2 pi k. And for this one, we're also going to do plus 2 pi k. Because that's to divide by. All right, so not nice numbers, but that's how we could find the next one. And if we were to graph this, if we were to go grab Desmos, I don't have it ready yet, so I'm not going to do it. And we were to graph a sine function, and then we graphed the equation y equals 0.8, we could see that intersection would be the 0.9273. This intersection would be the 2.2. And then this one would be whatever 2 pi plus 0.9273 is, right? And then so on and so forth. Okay, so this question, now they're asking us, let's see, when does the sine equal to -8/9? Well, we know sine is negative. Let's see, all seniors turn crazy. So I know sine's negative here, and I know sine is negative here. When I do the arc sine, because you know we're going to do that, we're going to get an output. We're going to get an output here. So it's going to tell me this angle right here. Well, let me erase that first thing I drew. I don't want that to confuse you. That's what the angle the calculator is going to tell us. So I'm going to, and they're also telling us on 0 the other thing. See how they're telling us in degree measure? Between 0 and 360. So on my calculator, I'm going to go to mode, change it to degree. This is one of the few times we're going to be working in degree mode. And I'm going to do second sine of -8 divided by 9. And the calculator told me calculator told me that red angle is -62.73 degrees. Okay, but they're telling me between 0 and 360. Well, if this angle, so this is my reference angle, right? Isn't this reference angle the exact same thing, the 62.73? So we need to find this angle. That'll be the first angle that's between 0 and 360. And then we need to find this angle. That's going to be the second angle between 0 and 360. So since I'm in degree mode, I want to take 180 and I'll add the 62.73, and that'll be that yellow angle. And then I'm going to take 360 minus 62.73, and that'll be the blue angle here. Okay? And that's all they want is those solutions there. We know there's only two because its periods only is 2 pi because that has a 1 in front of it, right? That's x is a 1 in front of it. The b is a 1. So that's all we have to do there. So now we want to find when is the tangent equal to 3. Now let's see here. We know tangent looks like this, from -pi/2 to +pi/2, and it goes up like that. Those are vertical asymptotes, right? Because we can't have a number divided by 0 on the unit circle. That's what we did with 6.2. So this graph looks something like this, and we want to know when is that equal to 3. Well, I only see one solution. Now they are saying between 0 and 2 pi, so that tells me we're going to have to, whoops, let's go back here. Come back here, so I know here is 3 pi/2. That'll be the next, remember, that's pi wide. And then the next range will be, let's see, 2 pi, but that's kind of like a midline, isn't it? And we're going to come over here to 5 pi over 2. So we're going to have, to me, it looks like we're going to have here, let me put on some vertical asymptotes here so I can give myself something to graph. So I know it's going to look something like this if I were to graph it. And I know it's going to cross here, here, and here. And so those are the 3 numbers I got to list. I don't really want to do all that work. What I can do is this. So I can find the arctan of 3, make sure I'm in radian mode, right? So I'm going to put my calculator back in radian mode. I'm going to do arctan of 3. I'm getting 1.249. And since I know the period of these arctan or these tangent functions is pi long or pi wide, here's k. So all I'm going to do is think about, now this is 6.28-ish, right? I'm going to just keep adding pi until I get as close as I can to 6.28. So pi is about 3.1415, close enough. Maybe 2, maybe I don't even want to do that. I'll add that. So what is that going to be? I'm going to do plus 3.142. So I'm getting 4.391. So there's one solution. Here's another solution. And then I'm going to add 3 pi, 3.142 again. Well, that's going to be more than 6.2, isn't it? So my graph was wrong. I evidently I can't add correctly. And so I went over past what I needed to. Is that because, that's because my graph, I had extended that at 2 pi was the midline, wasn't it? And I was graphing it over here. So that kind of makes sense to me now. Maybe back up and take a look at that video. So these are the 2 solutions for this equation on that interval. Now here's something, you can try it. Stop the video and try it yourself. See if you can do this. It's very similar to what I just did. So I'm assuming you did that. So I'm gonna do the arctan, whoops, I'm gonna do the arctan of 0.7. So let's see, am I in, oh, now I gotta be in degree mode, don't I? Mode, degree. So arctan of 0.7 gave me 34.992. So then I'm going to add pi to it, because remember that's plus pi k, same period. Well, actually pi, I'm going to add 360, sorry, because I'm in degree mode. So what's this plus 360? You probably caught me that I should have said 180, didn't you? 180. So I'm going to add 180 degrees to that. And I don't know, what, 299.4, what's that, 11, to 214 degrees. And if I add 180 again, I'm going to be beyond 360. So those are the 2 solutions for this equation on 0 to 360. Want to try it? I know we haven't done cosine, but I think you can do it. So here we go. I'm going to subtract 4. I'm going to divide by 3. So that tells me the cosine of some angle equals, isn't that negative 2/3? So I also know our cosine will give me output here, and over, so all trig functions are positive, only the sine and cosecant are positive over here. So I know the calculator, my arc cosine number or value is going to be this angle right here, which then I can find this reference angle, and tangents negative are positive down here, so that tells me there's going to be another solution right there. And it just so happens that that reference angle is the same as this reference angle. So let's go there. And I'm back in radian mode, right? So mode, radian, second cosine, arc cosine of -2 divided by 3. I'm getting t equals 2.3, 0.005. I'm going to go with 2.3. So that's that blue angle. So how do I get the reference angle? Well, the reference angle, this black angle right here, is going to be pi minus 2.3. I guess maybe I could do that in my head, but I'm not trusting myself right now. So I'm getting 0.84 is my reference angle. I know this reference angle is the exact same size, and that's going to be just pi. So what's that plus 3.14-ish? So 3.98. So those two angles are the answers. So this is the green angle, and the blue angle is there. I don't remember why I gave you the graph. So let's solve the equation and see how it works. I think those are the solutions, but they should be, I'm thinking they should be, oh, maybe because of this. Well, that's going to be one cycle. No, maybe it's not once, maybe on 2 cycles. Let's see what happens. So, but it's this, we start out the same way. We're going to say, what's the arc cosine of 0.2? So, and we're in radian mode, of course, so make sure your calculator, whatever your device is in radian mode. So we'll do arc cosine, second cosine of 0.2. I'm getting that 3t equals 1.369-ish. And then there's another place. So if we think about where is cosine positive, well, cosine's positive here in quadrant 1. It's also positive down here. Remember, all seniors turn crazy. So here in quadrant 1 and again in quadrant 4. So I think for right now, let's just write down. You know what I want to find out? I know the period is different here because of the 3t. So the normal period for cosine is 2 pi. If we divide that by 3, that's the period for this function here. And because it's 2 cycles, we're going to double that. Okay, good. Now I see what I did. So what we're going to do is we're going to write like normal everyday cosine has a period of 2 pi, so plus 2 pi k, and with the 3t. The other thing we're going to worry about is the other answer. I know this answer over here. Well, let's see. I know this angle right there is that angle. So that tells me this reference angle will be exactly the same thing. So to find this angle here, this red angle, I'm going to take 2 pi and subtract 1.369 from it. And that'll tell me that red angle. So I'm going to do that right now. So 6.28 is probably close enough. Minus that answer. So this angle, that red angle, is 4.911. It's 4.9105, so all around that. Plus the 2 pi k. And then we're going to divide by 3, 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 divide by 3. So let's see. What is that number divided by 3? So this is let's see. This is 0.4565 plus, let's see, what's 2 pi divided by 3? Since it's okay to have decimals, let's do that. 2 times pi is 6.28. I should have done that. Divided by 3 is 2.094 k. And then we're going to do that same thing down here. I'm going to get t equals, let's see, 4.91-ish divided by 3 is 1.637 plus that same 2.094 k. So now we're going to worry about, I've got to stop. So now I'm going to add this number to that. I'm going to add this number to that until I hit whatever 4 pi over 3 is. So let's go ahead and do that. Let's see, can I move this stuff? Here. I shrink that up. Shrink that up here. Yes. Okay, so I'm going to take what's 4 times pi divided by 3. So I'm going to stop when I hit 4.1. 9 I'll round to. So here I want this. Actually, I don't really care if I have this here anymore. So let's get rid of that. Actually, can I delete this without deleting everything? Yes. I don't really want to have this. Don't I want to have this? Come on. I want to move this. Now I don't know if it's going to let me. Okay, so I'm going to take 0.4565 plus 2.094. So here's one solution is 0.4565. The next solution there is 2.5502. Probably don't have to use that many decimal places. Then I'm going to add 2 again, and that's too big. If I add 2 again, I'm getting, or that 2.094 again, I'm getting 4.642, which is too big. That's beyond that. So those 2 solutions there. And here's one solution. And now we'll add 1.637 plus 2.094, and I'm getting 3.731. There's another solution, and if I add 2 again, what's 2.094? Oh, that's going to be 5 something. That's too big. So it's these. Here's the first solution. Here's the second solution. Here's the third solution. Here's the fourth solution. Now, if we go back and look at that graph that I was a little confused at, see that answer right there? See that answer right there? So that's the first 2 solutions. What I didn't include was the next 2. Okay, so that's how you can do that, and you got to keep going until you've done all the intervals. That's why those all solution ones are so much easier. Again, I don't know why I gave this graph. It's a really useless graph as it is, but that's okay. Let's see. So I'm going to isolate, solve it for sine pi t again. You've seen this before. So negative 2/3. So where's the sign negative? It's down here and down here. Now remember, the arc sign for a negative value is going to give us that. And it doesn't say anything about on a certain range, so that's going to be one of our answers. Well, we'll have to take care of the pi t, right? So I'm going to do arc sine of negative 2 divided by 3. I'm getting that pi t equals negative 0.7. Well, it's 97. Why don't I just go 3? Why not? And then that red angle is the negative 0.73, but isn't this angle here the exact same, except it's a reference angle, so it's not negative. And the way we get that is we're going to take pi and add 0.73 to it. So what's 3.14 plus 0.73? I'm getting pi t equals 3.87. And then sine has a period of 2 pi. K, and we're going to write plus 2 pi k. So now if I divide by pi, divide by pi, divide by pi, same deal down here. So negative 0.37 divided by pi, and I'm just letting my calculator do all this work. I'm getting negative 0.232 plus 2k. That's one set of solutions. That'll give me all the solutions that were here. And then for the next one, what's 3.87 divided by pi? That's going to be pretty close to 1. Yep. 1.23 plus 2k, right? So that's all solutions on that interval. So go ahead and try this one, and then and then I'll come back and show it, or you can just watch if you're really lost. Okay, so probably know the drill by now. I'm going to isolate the sine. So sine of pi over 2t equals negative 3 over 5. And then I want to think about, let's see. So So I know sine's negative here, and I know sine's negative here. And they're telling me between 0 and 2 pi, so the arc sine's going to tell me this negative angle. So I know I'm going to have to find the reference angles. Well, that reference angle will be the negative angle, and this angle will be the same. So to find that angle, I'll have to add pi plus the answer, and then this angle will have to be 2 pi minus that. So 2 pi minus the answer, and this one will be pi plus the answer. All right, so let's do that. And we're in radian mode, so make sure your device is in radian mode. Mine is, so I'm going to do arc sine of negative 0.6. My calculator told me 0.6435 radians. So pi over 2t equals, let's see, so I'm going to do pi plus that. So pi plus that answer is 2.022 plus 2 pi k. So they want two resolutions. I'm not sure how many I'm going to need. I know that period that is shrinking up the graph, so there could be more than 2 solutions in the answer. So I'll write it out this way as if I'm doing all solutions. And then the other solution will be it'll be 2 pi minus the 6.4 number, right? So 6.28 minus, actually, let me do this. So 5.6, I'll go with 6.4 since we're not trying to keep a computer happy, plus 2 pi k. So then I'm going to divide everything by pi over 2, or I'm going to multiply everything by 2 over pi, right? So what I'm going to do for the decimal portion, I'm just going to grab that number and I'm going to multiply it by 2 and divide it by pi. I'm getting 1.287 plus 4k, right? Because the pi's cancel out, and 2 times 2 is 4. And then we'll do the same thing down here. I'm going to take that 5.6 number, times it by 2, divide it by pi, so 3.588 plus 4k. And now we want to keep adding 4 until we get to 6.28, right? So this becomes, so here's one solution. Here's a second solution. To get the next solution, we're going to add 4 to that. I think there's only going to be 2 solutions here, looking at it. So 5.29 is the third solution, and then that plus 4. Oh wow, that's 7. So that's more than 2 pi. So we've only got these 3 solutions in this interval. Okay, that's how you do it, and that's the last example. Go ahead. I would highly recommend you try the exercises out of the paper, out of the packet, out of the textbook. Okay. And then you can go it'll make your My Open Math one speed along a lot faster.